Just to say, obviously tonight is about thermal imagery. So last time when we did the wildlife and technology webinar, I did just give a few examples of how we at Warwickshire Wildlife Trust use the technology. So just to recap, really, the technology that we tend to use is the handheld examples that you can see here. We use a Seek thermal camera. We've got a couple of these that we use mostly for our hedgehog surveying, which helps us to spot hedgehogs that we might otherwise have missed. We sort of did a bit of a pilot of this along with Regent's Park to see how well they work. We were quite pleased with them. The battery only lasts about 2 hours. That is the main handicap of these when you're out in the field. But they're quite a useful tool, and they're quite a good engagement tool as well for new volunteers. You can see a hedgehog here hiding under a bush that somebody walked past and didn't see at all. And then they were obviously seen with the thermal camera. See their nose just there. So the picture is a bit pixely. It's not the best. These cameras cost somewhere in the region of £300 and £400, which probably sounds a lot, but in the thermal imagery world isn't that much. But there's lots of other different types that you can get now, and sometimes attachments to your phone, which work in different ways. But yeah, just an example of how we're using it. And we're also starting to use static thermal imagery cameras in some of our woodlands to look at deer browsing, which is a problem in a lot of our woodlands and stops the regeneration of younger material coming forth. So we're trying to get a handle on essentially how much that is happening and where, and hotspots for it, and what species, and how we might go about mitigating against that, or using something like deer fencing, for example, to fence off different areas that we want to grow.
So today, as you know, as Debbie just said, we will be talking about thermal imaging, and I'm super excited to tell you a bit about that, as it's become sort of my specialist subject really over the years. So just to break down what we're going to do today. So first of all, I'll just introduce myself for anyone who doesn't know, and just tell you a little bit about how I got started with thermal imaging and how come I'm here talking to you today really. Then we're going to talk a bit about visual wildlife detection systems generally, so the kinds of ways that we might use technology to better see wildlife. Just to really sort of introduce the topic before we dive into thermal imaging itself. So then we're going to have a bit of a talk about thermal imaging and how it works, why we might want to use it, what we can use it for. And I also have some new images. I was just telling Debbie I've got some new images that I haven't shown anyone before, so I'm quite excited to share some of those with you. Then there'll be time for a Q&A. And I'll just tell you a little bit more about some next steps if you wanted to learn more about thermal imaging. So Debbie, if you could let me know when you want to break, if anybody, you know, wants to stop, if you don't mind just keeping time, Debbie.
Yeah, that's fine. Yeah.
When you want to break, in that it depends how much we get through, but let's see how we do. So for those of you who don't know me, I'm Kaylee. I'm a trainer, consultant, thermographer and bat ecologist, and I help lots of different people to get the knowledge and skills that they need to better understand and protect wildlife. And I'm really sort of on a mission to sort of help people to do the wildlife work that they want to do, whether it be in a capacity, a professional capacity, in terms of, as often people are generally ecologists or wildlife researchers, but also volunteers as well. So that's a little bit about me. And I told you a little bit last time, for those of you who are here, about my wildlife journey in terms of my career. I'm not going to tell you too much about that again, because I don't want to repeat it all, but I'm really lucky that I've had the past 17 years working with wildlife all around the world. I started off really always wanting to work with wildlife. I was that strange child that always would find a creature somewhere wherever we went, and I'd want to introduce it to everyone and make everyone else friends with the creature, whether it be a frog or a toad or whatever else I could get my hands on when I was small. And that has translated into me then getting into a career in wildlife. So when I was at school, I knew that it was going to be animals in some way, shape or form, but I didn't really know quite how that would work out. So I did my degree in biological sciences and really sort of specialised down into zoology, and eventually through some volunteering work got into working with bats. And after some years of working with bats here in the UK, I went over to the University of Southern Denmark to do my PhD on bats. And it was there where I actually first got my hands on a thermal imaging camera. So I just wanted to tell you a little bit about sort of the past decade, really, of working with thermal imaging briefly, sort of the story of really how I've come to this point of working with this technology. So when I was at university for my PhD, I was super lucky that I arrived at the same time as a shiny, lovely thermal imaging camera, which was worth then, I think, about £100,000. It was a high-speed thermal imaging camera. It's absolutely amazing. And I couldn't understand why no one was using this thing, particularly because it was such an amazing piece of technology. And I quickly realised that it wasn't as easy as just taking it out in the field or down into the lab and turning it on and pressing record. Thermal imaging, it turned out, was actually a lot more complicated than I had hoped it would be. And I know a lot of people often find that, but particularly with this camera, because it was a really high specification camera, so it was a high speed camera that recorded at 1100 frames a second. So the cameras I work with now are about 30 frames a second, so it's taking an image every 1100 times every second, which is kind of mind-boggling to me. But it produced some amazing footage once I actually got it working. But I realised why no one was using it. It was because they didn't have the time or the energy or the inclination to figure out how to use it. So after lots of trial and error trying to get it going myself, I was very lucky that my supervisor sent me back over to the UK to do a certification in thermography. So thermal imaging is a technical discipline, and it's used for lots of different applications, as I'll tell you later. But one of the ways of sort of training is to go down the technical route of getting certified as a thermographer, which is a job in itself, actually, not necessarily in wildlife, but lots of other different disciplines. And that got me started in actually working with this technology and actually getting some cool images whilst I was doing my PhD, to sort of get some behavioural data. So I was doing my PhD on bats, and I wanted to get sort of behavioural data on what the bats were actually doing while I was recording the sound, which was what I was actually doing my PhD on. So I did that, and that became a bit of a side project really for me in my PhD. And after I finished, I came back to the UK. I started working with a large ecological a large multidisciplinary consultancy that had a big ecology team, and they were very, very keen on innovative methods for use with wildlife, and particularly were really interested in the fact that I'd got these skills in using thermal imaging. So working with them over the years, I developed techniques for using this, particularly for bat survey applications, and starting to use it for other wildlife as well. And during that time also then went and got some higher level qualifications as well in using thermography. And after a while, I also went out to New Zealand to go and train a team out there how to use this gear as well. And I kind of found a bit of a love for training people and really sort of teaching people about this technology. And eventually I ended up leaving the company and starting up my own business to really be able to go out there and start passing on this message, I suppose, about thermal imaging. And I've been doing that and have been doing lots of different training since then, and also developing methods and writing. So I've been writing, produced some guidelines for thermal imaging for bats with the Bat Conservation Trust the year before, for some guidelines to help people to know how best to use this for bat survey work. And I'm also working on a book on thermal imaging for wildlife generally at the moment as well. So that will be more about the different species applications, but bats has been sort of the main focus prior to that. So that's a little bit about the sort of the journey of how I got to be doing this. And now I'm here to tell you guys about it. So I hope you'll find this interesting. So just a little bit about my background with thermal imaging. I'll now just briefly go over visual wildlife detection systems. Now, when we did our last talk back in December, for those of you who are here, we talked about something called the human wildlife detector, because there are lots of different ways of detecting wildlife, but generally this is the one we use because it's handy. We've got it with us all the time. But I want to just go back and have a little bit of a think about that and introduce it to those of you who are new as well. So the human wildlife detector is the onboard system that we're using to detect wildlife. And this is what the majority of people use. It's great because, of course, it's with us all the time. It's free of charge, and we have these fantastic senses, our hearing, our eyes, and various other things to help us to perceive what's going on in the world around us. But it also has its limitations as well. It's not a perfect system, so it has lots of limitations. We are human, and we have lots of different imperfections in our sensory systems. So there are lots of ways that we might miss wildlife if we're just relying on the human wildlife detector. And wildlife really give us quite a few challenges depending on the species that we are looking for. And it can really challenge us in different ways depending on what bits of our sensory system we're using. So as I say, different wildlife species give us different challenges, whether we're using our eyes or our ears. And for some, that might be that our animals might be in habitats that are particularly complex. So if we're studying animals in sort of woodland habitats, it can be quite difficult because there's a lot of foliage and it can be quite hard to see those animals, particularly depending on how camouflaged they are as well. It can be also that if we're trying to listen for particular animals, it might be quite difficult to actually hear them, depending on whether they're particularly quiet, or perhaps they are giving out signals that are above or below our hearing range. So bats above our hearing range and potentially things like elephants below our hearing range. So there's lots of things to consider in terms of using different sensory systems to detect wildlife. And thinking about those challenges and how we can overcome them is quite important. So there are lots of different wildlife detection systems, not just our onboard system. There are lots of ways that we can use technology to really help us to either extend the systems that we've got by sort of helping us to hear better or see better. And there are lots of ways, of course, as well to be able to help us to actually detect animals in a smarter way. So we don't necessarily have to be there. We can do things like putting out static equipment to be able to record things, and then we can come back and pick that up and look through it later. We use things like drones to actually get perspective on things that we wouldn't otherwise have. And something as simple as a pair of binoculars can help us to just extend the range of, in that modality, our vision. So lots of different ways that we can use technology to really complete our wildlife detection systems to help us better see and hear or detect in some way the wildlife that we want to find. So I want to focus now on vision, because obviously thermal imaging is a visual technology. I just want to think a little bit first about human vision a bit more. So as we said before, human vision is limited. So it's got a limited wavelength range. We can only see in a relatively short band of wavelengths. It's dependent on the light level. So for us as humans, we are going to struggle to see in lower light levels. And that means we suffer from something called visibility bias. So in higher light levels, we're more likely to detect certain animals, and in lower light levels, we're really much less likely to detect anything. And in complete darkness, we're really a bit stuffed, to be fair. The other thing about human vision is it varies from person to person. So as you can see, I've actually got my glasses on today, and yeah, my eyesight is terrible right now. I've just had to go and get a new prescription because I think the screen time this year has not been kind to my eyes. So it varies from person to person. My eyesight might be terrible. Yours, hopefully, is fantastic. But we have to be mindful of that when we're using just human vision to detect wildlife. And also it deteriorates with age. So when you're younger, it might be better, and as you get older, that is going to get slowly, sadly, worse. Another thing that people don't often consider is actually we do blink, and it's amazing what you can miss in the blink of an eyelid. Particularly, I've noticed this with my bat survey work when I've been out in the field, and it's amazing how much you can miss in the blink of an eyelid. So I will go back and analyse things, and the things that I find when I'm looking back over things is quite amazing. So it, particularly with smaller and faster flying mammals, it can be particularly tricky because of that. So as I said, human vision is limited. So you can see in this slide, this is the electromagnetic spectrum again, that you might remember from last time, I think. On the right-hand side, we've got the gamma rays. So these are the really short wavelengths. And on the left-hand side, we've got the radio waves. So they're the really long wavelengths. And right in the middle there, we've got the visible part of the spectrum. And it's that little bit there that the arrow is pointing to. That is the bits that we can see. And all of the rest of it, we can't. So it's really great to have technologies that can help extend that, to help us, depending on the different species we want to see, to extend the range of that vision. Another thing about human vision is that actually the mechanics of it are imperfect as well. So perhaps going back to your biology lessons, you'll remember looking at the eye. And it's not just the structure of the eye itself, but also all of the connections between there and your brain that are also not as simple as they might seem. So all of the connections and all of the things, all of this sort of process from actually the light going into the eye through to you actually perceiving it, there are lots and lots of connections in that chain along the way that can actually amplify the signal getting to your brain, or actually cut out the signal altogether. And so the thing with human vision is that actually if we're primed to expect something, we're more likely to actually detect it. And if we don't expect something, we're more likely to cancel that signal out. So if we go somewhere where we think that a species can't possibly exist, and it might actually be there, if we did see it, perhaps we caught just a glimpse of it, our brain might not even get that signal. So it's interesting to sort of think about that in terms of how our own systems are working. As I said, there's lots of different technologies we can use to help us to assist our vision. And this is the majority of the common things that people do use to help assist their vision to be able to detect wildlife. So first of all, we've got things really super simple like optics. So this is binoculars, you know, down to the very sort of simplest level. For me, I actually have a monocular because I can't see through binoculars. And I love I have a little scope, and I love taking it out with me because it's just super handy to be able to just see that little bit better and that little bit further. Then we've got things like camera traps and trail cameras, as we talked before. We've got image intensifiers, infrared reflectance cameras. We've got night vision and hyperspectral imaging, which is actually quite a new technology, particularly for this field at least, it's a relatively expensive, it's probably the most expensive technology out there right now for wildlife, or at least sort of this kind of application. And it is very much, I would say, in its infancy for things like this. But then we've got thermal imaging or thermography. And it's obviously thermal imaging that we want to be talking about today. But I just wanted to remind you that there are lots of different alternatives, and it's important to choose the right technology for the kinds of application that you're looking at. So obviously all of these have different pros and cons, and we're going to dive now into thermal imaging. So first of all, let's talk about what it is. So thermal imaging, or infrared thermography, is the science of acquisition and analysis of thermal information from non-contact thermal imaging devices. That's the official definition from the Infrared Training Centre that I did my certifications with. Amazing training place. And I can tell you that that sentence doesn't roll off the tongue particularly well, and doesn't necessarily make a lot of sense when you first read it. But I'm going to tell you what it means to me. So for me, it means that I go out with my non-contact thermal imaging device, which for me is a thermal imaging camera. Now there's lots of other devices that you can get, which I'll talk more about in a little while. And for me, that means that I go out, I acquire my data, so I'm collecting my data with those bits of kit. I take it back home nowadays, I analyse it, and hopefully I get answers to the questions that I was answering, which is often, was there a bat there or not? Was there a badger there or not? Sometimes more complicated than that, but that's what this means to me. And I like to define it just because there are other technologies that it does get mixed up with. But today we're going to be talking about thermal imaging or infrared thermography, or some people refer to it as thermography as well, just to make it super simple. So how does it work? So we'll go back to that electromagnetic spectrum again. So here again, we've got that spectrum of all those different wavelengths. So we've got those gamma rays on the right hand side, they're really short waves. If you move to the left of that slightly, you go into the X-rays. Hands up anybody who's had to go and have an X-ray if you've broken anything. Yeah, me too. So you'll have seen the results of imaging using X-rays. And then we move over into the ultraviolet, and we move into that visible part that we were talking about, that we're seeing with our eyes, we're picking up with our digital cameras we're using right now over Zoom. So that's what we're used to dealing with more than anything. Then we move over to the left of that, we're getting into the longer wavelengths, and then we come into the infrared part of the spectrum. And it's the infrared part of the spectrum that thermal imaging devices are picking up. So it's those wavelengths. And those wavelengths luckily are all around us. So these electromagnetic waves are naturally occurring in the environment. And the amazing thing about them is everything on this planet is giving off infrared radiation. So theoretically, we could use thermal imaging for pretty much everything on this planet, as long as we set it up correctly, we have the right kit. So I find that really exciting, and it means that it's used for so many different things now around the world. So globally, it's used for lots and lots of different applications. Most recently, of course, you'll have seen it probably on the news and things like that for use for COVID scanning, but it has been used in medical screening, in airports, and in lots of other locations as well prior to COVID. It's not a new technology in terms of that. Actually, you've probably passed through them many, many times when you've gone through airports if you travel, and never noticed them. So they are used quite widely. Also, it's used for things like condition monitoring. Particularly, it's used now in particularly in energy efficiency assessments for buildings, both for just normal homes, looking at how energy efficient they are in terms of their insulation and what they're letting out. but also for industrial buildings as well. It's used in lots of different research and development applications. It's used for medical applications, so it's actually been used for screening for breast cancer and lots of other different medical applications. It's particularly really coming out now a lot for use in veterinary applications, and particularly I think the great thing about it is that it's non-invasive, which we'll talk about more. We can really get some great data on it for things like that without going near the animals, which is fab. It's used for quality control in industry, where they're looking at processes and also in process monitoring when things are going on. So if you think of in factories where they're producing things, they use this a lot to really make sure that things are going right. What it can do is it can actually see where components in a system are heating up and predicting where things need to be replaced before they overheat and fail. So it can save companies huge amounts of money by sort of being there to help with that. It's using non-destructive testing and of course lots of security and military applications. So not necessarily wildlife, but I wanted to just give you some context as to what it can be used for, as well as what we're going to be talking about today. For us who are interested in wildlife, why would we want to use it? Well, for me, I'm just going to grab a sip of water, orange juice, so I can carry on. So for me, the main thing is that it's non-invasive. So in the middle here, you'll see a picture of me. I've got a little barber style bat in my hand. And I did used to really enjoy doing this, getting up close and personal and seeing the bats and working with them. But nowadays, I don't really need to for the kind of work that I do. And thankfully, that's a great thing right now as well, because we're not actually able to handle because of COVID anyway. So thermal imaging is great because it means we can get some really great data on the wildlife without actually having to touch them or disturb them in any way. So that's great because it means we don't have to go to the effort of going and catching those animals, but it also means it's better for them because we're not disturbing their behaviours and what they're doing either, and all of the implications of that as well. We can pick animals up at really long distances with thermal imaging, so we don't even have to get remotely close to them to be able to pick them up with thermal imaging, which is fantastic. So for bats, I can see them at tens to hundreds of meters away. For larger animals, things like badgers and deer, well over 1 kilometre away. So it's really, really useful for actually getting to detect the wildlife without going anywhere near it, without disturbing it in any way, which is great. The other thing is it's really accurate, provided that it's all set up correctly. It means that we can collect data where we're actually studying animals that is really much more accurate than we would be if we were just using the human eye. It can also be used 24 hours a day. So a lot of people do think that thermal imaging is just for use at night. Now, obviously, I love bats, so that's predominantly what I've used it for, but it can be used 24 hours a day, so it can be used for lots of different things. It's not just for nocturnal species. It can also save loads of money as well. So even though it's quite a high investment right now, often with projects we find that we save a lot of money because it can do an awful lot of work compared to a single person. So often for some of my applications, I can replace a lot of people on the ground and also get better data as well. And it's got health and safety benefits as well. So even pre-COVID, it was great because we were sending for nocturnal projects, we were sending less people out at night. Meaning that people were not as tired, and then obviously they're not incurring all of the health issues associated with lots of night work. But also now with COVID, obviously we're trying to reduce the amount of people we're sending out and reduce the amount of contact. With thermal imaging, we can get the job done with far less people, so it can have some really big health and safety benefits too. So that's why we'd want to use it. What can we use it for? So as I said, everything on this planet is giving off or reflecting infrared radiation. So theoretically, we can use it for pretty much anything. Some species are trickier than others, but these are some of the groups that it's been used for. So it's been used for terrestrial mammals, marine mammals, invertebrates, birds, reptiles, amphibians, and the list keeps growing. So there's lots and lots of different things we can use it for. So the pictures you can see here, we've actually got the seals up at Donanook in Lincolnshire, for anybody who's been up there and seen them, but I'm sure there's lots of other places to go, but that's one of my favourite, to go and see the seals over the winter. This is something that we're particularly interested in learning more about, because I think this is a really great tool that we can use to get more accurate counts as well, more easily, of those. And the picture that you can see down at the bottom is actually from a project that one of my colleagues worked on for her undergraduate thesis, looking at the use of thermal imaging for monitoring mammal tunnels under roads. So these tunnels in this picture that you can't see ever so well, but I'll show you some more pictures of later, monitored with the thermal imaging to see how the badgers were or weren't using these particular tunnels that have been put in specifically for them to get them under the road rather than across the road. So that's a couple of applications. There's so many different species we can use it for, and it's not just for mammals. So again, a lot of people think, oh, you need, hot-blooded mammals to be able to use this, but it's absolutely not. It can be used for lots of different species. And again, the list of applications it's been used for now is growing, and there's certainly a lot more research to do to really see more how we can use this technology for wildlife in the real world, which is very exciting. It's a very exciting place to be. So how is it used? I see it used in two main ways at the moment, and this is very early days in the use of this technology, but right now this is how it is right now. So generally we see people using it as a survey aid or as a survey method. These are the main groups, and there are little blurs in between as to how people use it, but generally we've got the survey aid, which is really just where people take out the device with them to really help them directly see what they want to see easier. So it's just extending that vision. It's really helping them in real time. So Debbie, something like with the hedgehogs, like, going around and actually scanning for them. Likewise, people are using it a lot for bats, taking it out with them in real time, sitting out there or standing out there with something like this scope to just help them to see better. And on the right hand side, we've got the other extreme, which is the extreme that I use most of the time, which is the survey method. So this is where we really replace humans pretty much in terms of collecting the data. So it generally means a more complicated system, as you can see there. So there's a lot more equipment going out, and it tends to be higher end equipment as well. So, but generally this is where we can get really high quality data, and we use it a lot for projects where we really want to know as near to the truth exactly what's going on as we possibly can. So those are the sort of two ways that I mainly see people using this technology. But I do think it will change over the years. So where are we with the use of thermal imaging for wildlife? I just want to tell you a little bit about that, because I think often it is important to really see where we are, I think, in terms of this technology being adopted by, I suppose, wildlife workers generally. So in terms of any technology, this is a great way of, I think, thinking about it, which is from a fantastic book if you're interested in technology. This is called Crossing the Chasm by Moore, and it's a really fantastic book. And it talks about how we as humans adopt new technologies and use them. And this curve is a sort of really describing the journey from left to right. So on the left we've got the innovators, and on the right we've got the laggards, and this is sort of the overall people picking up this technology. So this could be anything. This could be your iPhone, it could be a new computer, any technology. And we start off on the left-hand side with the innovators. Those are the people who just want to get their hands on it. Like as soon as it's released, you know, they'll be outside the iPhone store or whatever it is, ready to get their hands on it first before anybody else. And they don't care about any bugs it might have. They don't care that it might not quite work properly yet. They just want to get their hands on it and use it. And then we move into the slightly more cautious zone, which is the early adopters. And those are the people who they'll let the innovators deal with the initial bugs and get past that. They'll read the reviews and then they'll get on board with it. And then we come to something called the chasm. And this is kind of the bit that we jump over to get into the majority of people using a technology. So this is from really getting past those keen beans at the very beginning, going into really most people using it. And this is a really tricky one, and it's a tough one for any technology to really get to the majority of the people who would use it. So we get into the big bump in the middle, which is the majority of people, and then we get to the end, which is that laggard tail, and that is like the people who are super reluctant to use it, like maybe, you know, I suppose people who are just like, I'm not really bothered about that, I'll get it when I have to, and they'll wait until absolutely everybody's tried it, and then they'll jump on board once they're super sure that it all works and they can get their head around it. So that's generally how it works. Now with thermal imaging, we're at a really interesting place for using this for wildlife. Now with thermal imaging, generally we're a lot further along, but for thermal imaging technology for use with wildlife, we've been through the innovator stage. The people like me who, again, just wanted to get their hands on it, and when I started out using it, we really didn't know how to use it properly for wildlife. And there have been lots of innovators. And some of them have kept using it, and some of them have dumped it straight away. Particularly, I think, when they adopted it very early on, when the technology wasn't really ready for use with wildlife. Anyway, then we've gone into the early adopters, and they're people who have been using this technology in more mainstream applications. And I think right now we're at the chasm point, where we're at this interesting stage where I think the technology is now coming to a point where it's becoming more affordable. It has gone down in price dramatically over the years. And if you think right now that thermal imaging is too expensive for you, I wouldn't worry about it, because I think in years to come, it's going to become much, much more affordable. And definitely with the price drops that I've seen over the 10 years I've been working with it. So really, I think that there will come a point where we do jump into much more wildlife applications being viable for use. There are other things other than the equipment price that needs to help us get over this chasm. And I'm going to talk a little bit about some of those challenges with you next. But I just wanted to kind of explain where I feel we are right now with the use of this overall. So the main challenges that I see and that people tell me about as well are these three. So the challenges to really people actually using this technology for wildlife are generally expertise, equipment, and analysis. And those are three big ones. So first of all, expertise. For me, this was quite a big challenge when I started out 10 years ago, because there wasn't really much in the way of training or ways to get the knowledge I needed to be able to use this effectively. So when I started out, I went and got a certification in thermography. I did a very technical training, and I've sort of gone on to do more of that because I wanted to learn more and more about the technology. But there was nothing really that was wildlife specific. It was really very difficult to actually just get to know. There are lots of sort of scientific papers around, but really not much in terms of actually learning how to just use this stuff. So over the years, I've been developing training programs, and now we have training programs that we provide to help people to actually learn how to use this specifically for wildlife applications. And there are bespoke training as well that you can do. So you could go and get bespoke training with a thermographer who specialises in wildlife as well. I do apologise, I've got a really bad tickle in my throat and I will get past it hopefully. So the next challenge is equipment, and that's a twofold challenge. One is affording the equipment in the first place, but actually more than that is actually choosing the right equipment, because there's lots and lots of equipment out there, and there's more and more coming out now. When I first started out, the range was fairly limited, so you didn't have too much of a choice, but now it's becoming much more mainstream in terms of what's out there and available for lots of different applications. It means we've got way more to choose from, but that means that the choice is a bit harder now because we've got more choice. So it's tricky, because for wildlife particularly, it's really important you get the right specifications for the species you want to work with, otherwise it's not going to work. But it is great that there are lots of different types of technology. So here we've got things like the smartphone attachments, which are super cheap. I think you can pick those up for a couple of £100 now, which again might sound expensive, but in the scheme of things, it's very, very cheap for being able to actually use thermal imaging. So those little devices are pretty neat, because they have a low-grade thermal imaging detector in that unit, and they hijack the camera in your phone. And through the smartphone app, what they do is they overlay a low-grade thermal image over the camera image. So the camera, your visual camera, will do all the edge detection to make the image look pretty, and the rest is the thermal image. So they're really using a lot in terms of the software to create these nice images with those things. They're not the best for wildlife. For larger species, they can be useful, but generally for sort of smaller animals like I work with, they're not really appropriate. But they are a really nifty little gadget, and I think it's a really nice thing to actually be able to use to show people, and have something that's accessible to show people how things work. But then we've got all sorts of other devices. We've got things like the green one at the top there, that's a thermal imaging scope. There are lots of those now that are available. They're just little handheld devices that you can take out in the field with you. And they're quite nice because they're usually quite weatherproof, so you can take them out with you, whatever's going on, and just take it out with you to help you see better. Right the way up to sort of really high-end cameras like the one on the bottom left there. And then of course we've also got cameras that we can put on drones now as well, and some drones that have thermal imaging cameras as part of them as well. So it's quite exciting, all of the different bits of equipment. But it also is challenging because people don't necessarily know what equipment they actually need in the first place. So that's one of the big challenges, I think. But I do think particularly this is going to be a challenge that's going to it's going to get easier in terms of the expense, because the prices are really going down an awful lot. So I think as we go forward in the coming years, we'll see this used for more wildlife applications, and also we'll have more bits of kit that we can get our hands on. So another big challenge, and this I think is my biggest challenge really with thermal imaging, is analysis. So when we use this as a method, so this isn't appropriate for the aid. If you're just taking it out with you just to help you see, you don't need to worry about analysis. But if you're using this as a method, analysis can be a bit of a headache, quite honestly. So when we're taking this out and using it as a method, we're collecting our data, and then we're bringing it back and analysing it to find the creatures, the wildlife, and that can take a lot of time. For some species, it's relatively easy. For others, and depending on what you're using it for, it can take a lot of time, and it also takes the skills to be able to actually do that. So that is a challenge. We are working at the moment, and there are programs now to help us automate this procedure, and that's really exciting for me because it's going to hopefully make my life a lot easier as we go forward. So watch this space on that one. Before I finish talking about thermal, I just wanted to point you guys towards this project, which Lena, who works with us at Wildlife Tech, did this project as her undergraduate thesis. And she looked at the comparison between using thermal imaging cameras and trail cameras, and also traditional methods of really monitoring those mammal tunnels that I talked about earlier. So these are some more photos of her project here, where she was looking at these tunnels that you can see here that go underneath what was a new road for some of these. Another one is actually the M40. So you may well have driven over some of these tunnels. So they're a lot more established, and we know that badgers use them going under that. So for some people, they use putting down sand to look for footprints. Now, this is good in good weather, but if you have rain and all kinds of things like that, it can be tricky to pick them up. But also you can use camera traps at the entrances to look and see what's coming in and out. But in this project, Lena used thermal imaging cameras to actually look more at multiple tunnels, so she could actually see the entrances to the tunnels, but she could also see the wider landscape. And the advantage that she found with the thermal over the trail cameras was not only that she picked up drastically more wildlife, she could also see when the animals were not using the tunnels. So she had a few occasions where the badgers decided they'd scale 2 fences and the middle central reservation of the it was hair raising to watch, let me tell you, of the road. But it's really important data to understand how the wildlife are using the wider habitat, and this was a big thing of the advantage of using thermal imaging over some of those more sort of traditional methods. So yeah, if anyone's interested in learning more about that, then do let me know. Okay, so I'm going to show you now some images. Now, obviously, this isn't a thermal image, but I've been going out with my newest thermal camera to get some images of wildlife. Unfortunately, these are in captivity, the images you're going to see, because sadly, lockdown and COVID and all that means I haven't been able to go and necessarily get the image I wanted. So I've been testing it out. These are a couple of places where I've been able to at least go and see some different species to go and get some test images. But the great thing about this camera that I have at the moment is that it takes both a thermal image and a normal digital camera image as well, and they're paired. So what we can do is see the difference between what we see with our eyes, or at least a visual camera as a proxy for what we see with our eyes, and what we would see with the thermal. So as I say, I'm sorry they are captive ones, but it's really just to sort of show what the difference between what we can see, or at least what we can easily see, and what the thermal camera shows. And these are images I haven't processed at all. So I'm going to show you some a bit later that I've processed, and you can see them even more clearly. But this is just straight off what we see with the camera. This box, this was just a test, and you can't actually unfortunately see it, but this actually had a captive mink in it. So this one, we just wanted to really see if we picked much up with it. Now you obviously can't see the animal inside, obviously having a nice sleep in there, but just interesting to really look, I think, at the difference between what you see with the thermal and what you see with your eyes or with the digital camera. So I'll just run through a few of these. So hopefully you can see an animal there. Now these, my husband did complain a lot because I spent ages with these guys, and I have got some video footage as well if we get time to show you of these guys. But actually I think if you're out about, it was really quite difficult to see them with your eyes. And these are some of the images that we got with the thermal, and I think they're just beautiful creatures, so I loved getting these images. But it was just so much clearer seeing them, just being able to pick them up against the background. And this is relatively open in here, but I think if they were really out in the woods properly, it would make a big difference to what you could actually pick up. So just to give you a bit of an idea of what we could pick up with the thermal, and I will show you some video as well later if we get a chance. just what you can see with it versus what you can see with your eyes, which for me is the big thing. It just makes it so much easier and clearer to see things. And I think there's just so much for potential for using this for lots of different species, but particularly, I mean, these guys they're pretty nicely camouflaged against the background. So yeah. Just a few of my, I got quite obsessed with wolves. Sorry, guys. See, that one I couldn't really see all that well, but actually when you see on there, you can pick it up quite easily. These ones don't have pairs, so I will skip through these. This one's interesting because you can actually see a heat patch on the ground because he'd been laid down and he'd just got up. And I've caught this quite a few times, and you can sometimes get footprints as well with animals. That's really quite cool to see. This one's interesting. So not the nicest picture ever, but you probably can't see an animal here. But I'll take a guess if anyone wants to guess what we're looking at. Whether you want to drop it in the chat or just shout out. No, nobody can guess. I'm not seeing anything. Okay. These were actually unexpectedly seen by me. So I can't remember whose enclosure this was. It wasn't the enclosure inhabitant that we were seeing. These are actually flies on the log on the food. So you can see those 3 little dots there. They were flies. And I couldn't believe it. I really didn't think that I would see those because I couldn't really see them with my eyes. And then when you saw through the camera, it's like, wow, that's really cool. So yeah, that's just an odd observation. And I often find this with taking the camera out places that you see things that you wouldn't imagine you would see anyway. So it's quite interesting. Can anybody see who's here? I don't know whether anybody ever goes to places like this and is just trying to desperately find what is actually in there. I'm really terrible at spotting things. But again, as I say, my husband's really good at finding them. Anybody spot this creature? No. Okay. I think this is an owl. And again, like, look how much it really stands out. Like, and these are unprocessed, so I haven't done anything to these images. They're just what the camera saw on the day. But if I process these, and you'll see later, it'd stand out even more. So again, you can actually see him there. But yeah, I do think it's quite interesting to see the difference. This is a fox. He was really tricky because he was massively on the move when I went, so he was very hard to get any decent pictures of. I got lots of blurry images of this guy, but I've just picked a few out that you can see. And in this one, there was actually a mirror in there, and they put lots of sort of enrichment things in his enclosure for him. And there was a mirror, and you can actually see the reflection as well as you would in a normal mirror as well. That's another thing about this, is it can't see through glass. So you couldn't, if ever I want to go and get stock sort of images and test things like this, I have to go to places where the enclosures are fenced and they're not glass, because the thermal you'll just get a reflection of yourself back, which is quite weird to have to say when you first see it. something we're more likely to see probably for us is deer. It's these guys. And I was quite lucky because I had a nice view of these, so it made it nice and easy. I thought it was quite interesting with these. I could see sort of patterns in the coat as well, and it's something that I thought was quite an interesting one, because often you don't. With the zebra, you can actually see patterns in the coat, but other things you can't. Quite interesting. This guy was another one I spent quite a while taking some pictures of.
So Alex has asked whether the pictures are actually showing the correct temperature differences.
Good question. No, they're not. So if we wanted to get the real temperature, first of all, that's complicated with biological items because there's so much variability. But with any object, if we wanted to get the real temperature, the camera is only ever telling us the apparent temperature. It's telling us what it thinks the temperature is. What we can do is calculate the temperature based on the different variables and conditions. So we'd need to know lots of different things to calculate it, but we could get it relatively close to what the real temperature is. But it is very misleading because some objects can look a lot hotter than they are, and some objects can look a lot cooler than they are. And there are lots of things that sort of can feed into that and make that happen. So it's a complicated one. But so no, this isn't the real temperature. Also with these images, like it's all in terms, even with just the apparent temperature, it's important to think about the scale on here, because sometimes if I don't put this scale on here, in fact, even sometimes if I do, people will often react to these images and say, oh, that looks really hot, or oh, that looks really cold. But in actual fact, it's just the way the image is set up. There's lots of things we can do in here that might make things look hotter or colder. So it can be a little bit deceptive, and it is often a bit of a longer story than that. I hope that answers the question, but do ask more if you have more questions while we're having a look. As I say, these are all unprocessed, so I haven't done anything with these. This is just what I picked up with the camera. It's just to show you sort of the difference between what we see with our eyes and what we're seeing with the camera. I think that's the not quite the end of these. So then I want to take you and show you some of the ones that I have processed, so you can see what the difference is.
And Sally's asked in the chat whether the patterns that you can see in the coat, like on the deer or the zebra that you mentioned, is because of the different heat absorbency of different colours.
Yes. Yeah. So we talk in thermography about a property called emissivity, which is how much different materials will emit heat. So that's one of the ways that we see things that look hotter and colder. So yeah, and with some coats it does, some coats it doesn't. So it is really variable. And the thing with animals is there's so many variables going on compared to a lot of other uses for thermography. Like there's lots of uses for thermography that have far less variables in them than we throw in when we're working with animals. So so yeah, that's those ones. So what I think I'll do, I'm happy to answer any more questions as we go through, but I'll move on and I'll just show you, in fact, while I'm here, I'm going to just show you one of the wolf videos, and then we'll go over and look at some processed images. But I'm happy while we're doing that to take some questions if you guys have any more questions. Yeah, feel free to keep throwing those at me.
Alex just asked what the fancy word again was.
Emissivity. I'll type it in the chat in a minute. And it's a really sort of core kind of principle in thermography that it can really change the way things look. It can be really useful though. So if you wanted to mark something, and this is something that I would actually quite like to try if ever we were allowed near animals again, is you can use different emissivity markers to show up so you can get little dots and things like that, and you can even get like it's a little bit like nail varnish. It will show up looking either really hot or really cold, and I think it could be quite useful for like spotting things, and perhaps identifying individuals. So yeah, they do that with other things where they want to really mark things so that they can just see it really well. So I'll type that in the chat when we get to the end of these. Bear with me. Yeah, I think that is the end of those. So let me just pop it in there. Emissivity. There we go. So let me just come out of here. I'm just going to have to reshare my screen as well, I think, when I get to it. But
Katie's asked if you could only have one item for thermal imaging of any price, what would you have, assuming you also need a laptop for the analysis as well?
Oh yeah, I've kind of bought it, the one that I really wanted, but I think the next step because I've just bought the T10, the 30 SC, which is like, it's kind of the highest end one you can get without it being like a military grade thing. But what I'd quite like to do next is drones. But I particularly wouldn't want to fly the drones. But what I'd really love to do is be able to get some of the drone data. So I think that would be something that, yeah, with unlimited funds would be great. The next thing I am actually going to get is a scope. So I'm looking into doing that, particularly really for teaching people to sort of help people to kind of get to grips with it. So, but yeah, I think if funds were no object, thermal drone would be pretty cool, but I'd need somebody to come and fly it for me. So if anybody wants to do that, let me know. Right, let me see if I can get these moving again, because it doesn't seem to want to let me do that. Can you see? Oh, it's paused again. Hang on. No, my screen share is not following me, and I don't quite know why. We'll get there. We will get there. Share screen. Okay. Can you, hopefully, I can't see it now, so it's no good me asking you if you can see it. Can you see a photo now?
We can see thumbnails of photos.
Ah, okay, you share. Now?
Yeah, so we can see clouded leopard.
It just kept dropping out. I don't know why. So yes, clouded leopard. So these guys were pretty amazing, and relatively easy to see right here, but actually out in the places where they would really live, probably not that easy to see. So what I wanted to show you is actually the images of, these are some of the images I've actually processed. So these are ones where I've actually gone into the software afterwards and really pulled out a lot of the rubbish that I don't need to see, so I just see the animal. And this is the kind of thing that we can get when we use thermal imaging using the method. So these are lots of different processed images. So you'll notice these are a bit different in terms of the colours that you normally see. And the thing with thermal imaging is it doesn't have to be that standard colour palette that you usually see. So if you see thermal images in the media, generally you get what's called iron bow, which is that sort of orangey purpley one. You'll also get black and white as well, but it doesn't have to be that colour. There are packages where you can turn it any which colour you want. You can create your own colour palettes. And really it's about using colours that really make the animals stand out best. Now, for me, I have certain palettes that I like, but it also depends on the kind of habitats they're in as well, what works best. So it can be this kind of part personal choice and part really sort of making sure that it stands out well. So these are images again that like I have spent a bit of time actually processing to pull them out. So it's the raw thermal images would have been a bit harder to see than these. And there are softwares that will automatically help with this. There's lots of visual processing tools you can use. But I think with wildlife that, again, there's so many variables, it's at the moment most feasible to do this manually to pull things out. So just take you through briefly some of these that we got. So this one, if I can make it go back, this is the raw image that I first got without having processed anything. And then this is what we can pull out to actually try and make them stand out more, to help us see them better against the background. The process called thermal tuning, sometimes people call it, but I've heard all sorts of other terms for it as well in thermography. So as you can see, there's lots of different colour palettes that you can use, and it really depends on the species you're working with, the habitats that they're in, what works best. Now, it's also used a lot in veterinary applications now, more and more, and it's particularly attractive for wildlife veterinary applications because it means we don't have to go anywhere near them. And for veterinary applications, there are particular palettes that the vets like to see that's kind of a standard as well. So that's something that you might also notice if you ever see these coming up. So this one was an interesting one because it was really actually quite bright sunshine for this one. And I was really confused with this image. So this is him just in the visual image sitting there. And then I was looking at this image. Now, normally, whenever I take pictures of animals, the eyes normally show up really, really bright white. It's just quite obvious usually in thermal images, and it's also something that people use for wildlife, particularly if they want to measure core body temperature. They tend to use the eyes or the parts of the eye as an indicator of core body temperature. But I can't really see his eyes here, which is quite weird. And then I realized he blinked for the photograph. So it's like, this is really weird, what's going on? Yeah. Again, like you can really see there's quite a lot of difference using different color palettes and different processes to make him sort of stand out. And yeah, was very, very bright sunshine, so I'm not really surprised now that he was blinking. Again, that's what it looked like on the camera, and then we processed it to really sort of just get as much as we could with him. This one's a little bit eye-boggling, as they can be. But I just wanted to show you sort of a little bit more about, you know, what we can do with the images if we're processing them further. So I think that's everything. Oh no, I have more. My computer had gone on a bit of a go slow. We also do use this for building surveys for bats in consulting, and this is a particularly nice one there as an example. One of the nice things for using this for bat surveys is we can cover these massive buildings with just cameras. Or, like, I personally can use a couple of cameras to cover lots and lots of surveyors worth of work. So this building would be really tricky to cover with normal surveyors with just using bat detectors and their eyes, but with thermal we can cover really big buildings like this if we wanted to. And then there's my bison again. These are quite interesting. So this these were deer, and I kind of struggled to see them in the image, but then when we look closer, quite interesting to see them sort of jump out. So how many deer can you see in this photo? Anybody want to drop me a number in the chat?
Six.
Yeah. Yeah, you're doing all right. I can see 5 now, but yeah. So that's I think this is the raw thermal image. That's the visual image. And then this is the processed image. So yeah, it does definitely make it easier to spot them. And these ones really just lit up like light bulbs in the woods. So that's super cool. And that's an unprocessed image and a processed image there as well. And these, I wasn't really supposed to be looking for these. This was an elephant enclosure, but some ducks that again just really lit up compared to the visual. And finally, I think the rhinos. I didn't get quite the images I wanted here, but I got something. So that's the unprocessed image, and that's the processed image. It's a visual, different color palette, and then much more processed. So yeah, that's everything I've got for you today. I just wanted to show you those. Are there any questions that I've missed in the meantime? Has anybody got any more questions that they'd like to
So there were a couple in the chat.
Yeah.
So Alex has asked a couple. So
Yeah.
for example, what software do you use to bring out those colours to make it different?
So we use specialist thermal imaging packages. So I personally use FLIR packages. So there is one called FLIR Tools Plus, and one called Research IR Max, and the latest one that's just come out is called FLIR Studio. But different manufacturers have their own softwares as well. So if you have a different device that's made by someone else, they'll generally have their own software package, and they're all sort of fairly similar in terms of, you know, what you can do in terms of what the wildlife stuff we do. I also use some video processing software to trim my videos, just to get the sections out when I want to. And yeah, I'll send you a couple of videos, Debbie, and then you can share those with the guys if they want to see those. I'm sorry, I couldn't get my screen share working. People do also use those people who are super talented and can do coding. They do also do image processing in MATLAB and in R as well, but I am not that smart, so I'm not going down that route.
I had to use R for a lot of my postdoc stuff. Yeah, it was hard, very hard.
Yeah. I used MATLAB a little bit when I was doing my PhD, and I really don't want to ever have to deal with it again.
No,
but it's a shame because I know it can do loads of really cool stuff, but my brain is not wired for that kind of thing. So
if anyone's into MATLAB and R, you know,
yeah, give us a shout.
Give Kaylee a shout.
Yeah.
So the usual color palette you mentioned that they often show pictures for like the news and stuff. Was that iron bow?
Yeah, they usually call it iron bow. Yeah, and that's the kind of standard that you see in most things. And then some people will use the black and white. The black and white is tricky, I think, because sometimes it can look more like an infrared reflectance image, which is a different technology. So it can be quite deceptive, because sometimes you're kind of looking at it like, is that thermal? Is it not thermal? Like if people don't actually say, because sometimes you'll just get images putting things and be like, what is that? So the black and white can be a bit deceptive sometimes, I think.
I tend to use like a purpley black orangey type color mix for the hedgehog surveys. That tends to work quite well.
Yeah.
Stand out more.
And I do think it is, there's so much like about your personal preference, like what stands out for you, because I think sometimes for me, like there are palettes that I'm like, oh no, I'd never use that, but some people absolutely swear by them. So it's, you know, it's obviously a little bit sort of personal with what helps you to pick things out best. So
So someone said that they looked at the cost of thermal scopes and they tend to start about £1,000. Is that the case, or is there some secret cheap ones that are amazing?
I have seen some cheaper ones recently, but I haven't really had a chance to suss them out. So I'm sometimes a bit skeptical when things look a bit too cheap for what they do. So, but I haven't had a chance to do any more research on it. But what I would say is the price is coming down a lot. And I think particularly with those handheld devices like that, because they produce more of them, the more of them they make, the cheaper generally they get over time. So I would say that those kind of devices are likely to get cheaper in the long run. So, but I'd say £1,000 sounds about right for a good sort of standard of scope, really. But as I say, I've seen cheaper ones, but I haven't had a chance to really suss them out yet.
Cool. And presumably you wouldn't really get the quality of the type of pictures that you just showed us with an iPhone attachment.
No, it's much lower resolution, so they're much sort of grainier images than you would see with the ones we've got. So the images I've just shown you, that camera is a 1024 pixels landscape. I can't remember what it is across the side, but that's the highest resolution you can get just if you buy one as a normal person. You can go higher than that if you sort of, for military grade stuff and like things you might see on National Geographic and the BBC. Those cameras are like military grade cameras to be able to get that resolution. So the resolution overall of thermal cameras is very low compared to what you might see on your television. So HD in thermal is 1024 pixels by, I think, 700 and something. I'm not sure what HD on the TV is, but it's a lot more than that. So if you're used to things like that, you might be slightly disappointed with it, but it is getting better, definitely. But those iPhone ones are very low resolution. So yeah, you would get a much grainier image. The way that they get those images that look more detailed with the iPhone ones, as I say, is when they're overlaying the camera picture with the thermal picture, and it's quite a smart thing to do, but it won't help so much with wildlife detection because well, at least for those of us who are using it at night or in low light levels, because it needs a certain level of light to get to put those edges in from your camera.
Cool. And have you looked at any plants or trees or vegetation with a thermal camera?
Yes, and it looks awesome. There's so much variation, and I think what's interesting, particularly with trees, is the structure, but also things like rot and damp in trees as they age. You can see so many just differences, and I'm not an arboriculturalist by any way, shape or form, but I do find it really interesting. Like it's really interesting what you see with it. And I do just find it really fascinating to just take the camera out and look at things, because you get such a different perspective on things, I think. With the vegetation, in terms of like real life applications, I think it's really interesting. They're using it a lot in agricultural applications to like look at plant health. So particularly with the drones, they're using it to look at crops and things like that to see how healthy the plants are. They also do use hyperspectral as well to do that. And I think that could be something to be really interesting in sort of from more of a conservation perspective for analysing and looking at habitats as well. But there's really not been a lot done on it. So it'll be interesting to see in the coming years what comes out of it. We are generally like quite behind everybody else in the use of this technology, so it'll be interesting to see what comes of it.
Great, go Elle, go for it.
So earlier you said that the process of it was becoming more automated, I think, like to help you, I guess, like look at the data. What would be involved in the process of making that automated. Does that make sense?
Yeah, it does. It does. So there's various different ways of going about it. But the thing for me, what I generally need for my stuff is I'm wanting to detect things. So the biggest challenge to me is detecting bats. And that's quite a tricky one for a human to do anyway. But there's lots of software out there already that does movement tracking. But what we're trying to do is get some more wildlife specific tracking and identification software to help at least semi-automate it. So with the bats, that would be seeing that there's a moving object. And then, so there's lots of ways that they can do that in the software, but then that registers a timestamp in the file when that was, so that myself or one of my team can go and look at that time and see whether it was a moth or a bat or a bird or whatever it was, because there's so many other things that it could be. There's some really good success actually with the artificial intelligence now with bigger mammals for actually identifying them from thermal images. So particularly they've done it with things like elephants and things like that, where they've had thermal stuff running, collecting data and getting the AI software to just automatically identify, and they're having a lot of success with that. But the smaller stuff is trickier. So that's a work in progress. They've got some great bat tracking software over in the US, but in the US they tend to just be tracking bats more in the wider habitat, whereas here in the UK we're tending to look at roosts, so it's quite a different pattern that we're looking for compared to what they're looking for. So I hope does that answer the question?
Yeah, definitely.
Okay.
So
yeah.
So you wouldn't have to sit there and look through all of the footage, I guess.
That's the dream. That's the dream. It's just doing the bits that it really requires a human for, because I think with all of this stuff it's about working smarter and not harder, because we can do so much more with our time to really sort of get better data and more accurate data without sitting there for days on end, which I have done and I'm looking forward to not having to do. So, yeah.
Thank you.
You're welcome. Thank you. Great question. Are there any more come through, Debbie, or are we okay?
I don't think so.
Okay.
I guess an observation from me. So I've gone out sometimes on bat box checks where we've taken quite a high spec camera, not mine sadly, but we've only been able to see that bats were in boxes from the outside if there were a lot in there, like, you know, quite a big maternity roost. And it didn't seem to work for smaller clusters of bats, presumably because the heat that was given off just wasn't radiating out enough. And I've tried our little handheld ones on dormouse boxes, hopefully to look to see if there were anything inside, and they didn't seem to work for that, but they weren't as high spec camera either. But yeah, just an observation really that sometimes I think you need quite a lot in there.
It's one of those things that I wish we could really reliably use it for, but I don't think we will. Like, I think it's something that we can maybe use, particularly in like COVID times where we can't go and handle things. But I think that the tricky thing with the boxes is that we've got, when we have torpid animals, there's no chance we're going to see them anyway. And you really do need quite a lot of heat in there to come through, and again it depends on the bat boxes as well. So with the wooden ones you're going to get lots of variation. With the concrete ones or whatever they are, they're going to be relatively stable from box to box, but obviously, you know, it's tricky. It's going to be a lot trickier to see what's going on. The other thing with the boxes is, again, that emissivity thing where damp and things like that and all sorts of things as they age can change the heat signature of how it looks. So that's just throws another variable into the mix that makes it complicated. So, but it would be so nice to be able to just go out and go, right, yeah, there's bats in there. whatever. But and also then you've got things like bees and all sorts of wasps' nests and things that can give off heat. I saw a picture a while ago of someone had found a big bee's nest in a chimney breast, and actually they had got the thermal on it and seen it, but it was one of those where it's like, had it been a thicker wall, you probably wouldn't have seen it. It was just, you know, it was one of those situations where it's like, you get lucky sometimes with it. And I think it's difficult because you do get examples like that where you're like, yes, we could see it, but there might be 10 more cases where they would have been there but you wouldn't have seen them, and that's where it kind of, yeah, it gets tricky with these things.